Hello, everyone. Today I'm going to be talking about the relationship between higher temperatures and other environmental factors in Barataria Bay. These factors specifically being salinity level, chlorophyll A concentration, and dissolved oxygen content. What I'm attempting to do through this research is gain a better understanding of how rising temperatures impact our coastal systems. Select studies have shown that in coastal areas, both salinity levels and chlorophyll A concentrations can be positively correlated with higher temperatures, and that dissolved oxygen content can be negatively correlated. The prediction/hypothesis for the project aligned with the relationship supported by the studies, and the figures were created in order to see how rising temperatures in a specific coastal area, Barataria Bay, were influencing salinity, dissolved oxygen content, and chlorophyll A concentration. So for some background, Barataria Bay is an inlet of the Gulf of Mexico, and its location makes it a coastal waters area. Rising temperatures in this coastal system could possibly exhibit clear relationships that were previously mentioned. To find out how if the trends seen in other coastal areas were present in Barataria Bay, a few figures were made. Hydrological monthly data from two CRMS stations were used, and in this map here, you can see the Barataria Bay with the two stations being marked with a yellow triangle and blue square. These stations had data that was used to create the following figures. The purpose of using two different stations was to have a wider range of data to better accurately see how temperature affects different environmental factors. Our second figure here is just showing the temperature fluctuation from 2016 to 2020. And you can see from this this figure, that the temperature is pretty consistent in its values, and these values were used for the figures I speak on later in the presentation. All data for all figures, including the map, was found through the CRMS Wetlands Data Download Form, specifically their Hydrological Monthly Data Request Form. This data was then plotted in MATLAB to attempt to display trends between temperature and other variables. Figure 3 displays the relationship with temperature and chlorophyll A concentration at both sites. You can see here and in the caption that the slope for the trend lines from both stations have positive slopes, showing that there is a positive correlation between chlorophyll A and higher temperatures at both stations. In figure 4, you can see that through the trend lines for data at both stations that there is a negative slope, meaning that there was a clear negative correlation between salinity levels and higher temperatures. This slope can also be seen in both the trend lines having negative values for their slopes. In our last figure, the trendline equation for the first station, the Swamp 0011 station, there is a very small positively correlated relationship with higher temperatures, whereas there is a clear negative correlation at the second station. So to bring it back to the original prediction for this research, we can confirm through these figures and the associated trend lines that the prediction was incorrect for the trends for salinity, since the figure showed that there was a clear negative and not positive correlation with higher temperatures. And the data for dissolved oxygen content was not consistent at both sites, so an exact conclusion for the trend cannot be confirmed. However, the relationship between chlorophyll A concentration and higher temperatures did turn out to be positively correlated as predicted. And just to reiterate, all the data used to plot these figures was taken from the CRMS Wetlands Data Download Request Form. The station locations were also found at this website. Here are my references, including the software I used, studies I referenced, and the site used to obtain data. Thank you for tuning into my presentation. I hope to conduct more research concerning coastal systems and important variables in the future.